Hello, students. This is the Module 17 quiz, ready to go on page 553 for the Math 7 Accelerated. And uh, and I'm going to get this is for Math 8 too, 8th grade math. I'll get that page in just a moment. So the the first one here, representing linear non-proportional relationships, complete the table using the equation 3x plus 2. And well, let's see. What we got is, I got a piece of paper here. So y equals 3x plus 2. So y equals 3x plus 2. And we have first -1. Let me zoom in here. So we have -1. So that's 3 times -1 plus 2. That would be -3 plus 2, which is -1. And so this would be -1. I think I'll use a pen, black pen. That'll be easier to see. So, -1. Yeah, just a little bit. Okay. Do I have another? Do I have another one here? Because maybe not. All right. Anyway, enough time wasted. 0. So we have y equals 3 times 0 plus 2, and 3 times 0 is 0, plus 2 is just 2. So that should be 2. And then 3 times 1, well, can we just do this in our head? 3 times 1 is 3, and 3 plus 2 is 5. And then 3 times 2 is 6, plus 2 is 8. And 3 times 3 is 9, plus 2 is 11. Now, one thing to note, just to make sure I have this right, uh, it goes up by 3 as I increase the x's. So this increased by 3. Yeah, that increased by 3, by 3, by 3. Okay, that was just an extra check right there. Okay, next we have find the slope and the y-intercept of the line in the graph. So the slope and the y-intercept. So the slope and the y-intercept. Let's bring it in tight here. And maybe I can do it again. Yeah, okay. So the y-intercept is going to be easy. That's just +1. That's where it crosses the y-axis. I'll put a dot right there. Okay, so that's 1. The y-intercept is 1. And the slope, well, I have to find out where does it cross the grid again, and it does so right here. So the the slope is going to be the rise over the run, so it's up 1, 2, 3, and over 1. So the slope is up 3 and over 1. And if you can make that, it is a fraction, but if you can make it a whole number, we usually do. So 3 divided by 1 is 3. There's that. And let's see what else we got here. Graphing the linear non-proportional relationships. So we're going to graph this equation 2x minus 3 using the slope and the y-intercept. Well, the y-intercept is -3, and that's your starting point. So we go to -3 on the y-axis. So 1, 2, 3. Right there, and then we use the slope of 2, but 2 is the same thing as 2 over 1. So that means I'm going to go up 2 and to the right 1 from there. And so I'll bring it in tighter. I'll go up 2 and to the right 1. And I can keep doing that, up 2 and to the right 1. That just keeps that whole thing going. I can go also on this line right here, I can go down 2 and back 1. And then here, I can just draw my line. Right here. Boom. Easy right there. All right. There's my line. It's an okay line because when I look at this here, if I go up 2 and over 1, I should have been right there. So it was okay. But yeah, it'll do. Okay. Next. We have, does the table represent a proportional or a non-proportional linear relationship? If it's proportional, um, then y over x will be the same in every case. So y over x, that is 4 over 1. You know, the y value over the x value is going to be 4 over 1. I'll bring it in tighter here. And then 8 over 2. I think you have to check all of them just in case. 12 over 3, 16 over 4, and 20 over 5. 4, 4, 4, 4, 4. So that is definitely proportional. Okay. And then the next question is, does the graph in exercise 2 represent a proportional or a non-proportional linear relationship? So exercise 2, if we remember, is up here. And this one here, this is non-proportional because it does not cross the I'm sorry, it does not cross the origin. It should have crossed right there. That would be proportional if it was a straight line through the origin, but it's not a straight line through the origin. So for number 5, I'm going to zoom out again. Number 5, it will be non-proportional. And then does the graph in exercise 3 represent a proportional or non-proportional relationship? And number 3, if we remember this one, that one also doesn't cross the, it's a straight line, but it has to cross through the origin. So this will be non-proportional. And then for this last one, we have how can you identify a linear non-proportional relationship from a table, a graph, and an equation? And I have the answer here. For a table, that would be so for an ordered pair, 0y. Y will not be 0. Y will not be 0. And in a graph, the y intercept, intercept, will not be 0. And in an equation, so for an equation, we have y equals mx plus b, where b is not equal, that little thing means not equal to 0. So that is that's what we got for that, and that's all you need to know. Thanks for watching.